Hello, this is Mike at Gamefromscratch, and welcome to a brand new tutorial series we're going to be doing here. This one's going to be a bit different in that I am no subject matter expert on what I'm about to cover, and I am also going to be doing two tutorials at the exact same time. As you may be able to guess from the graphic up on the screen in front of you, I'm going to be looking at Unity 5 and Unreal Engine 4. Both of them have had pretty major news recently, major changes in the licensing structure. They're completely free to get started in both levels, and I mean to get started, all the way up to making a certain amount of money completely free. I'll get into the specifics of that in a little bit. That's a key distinguishing factor between these two products. But essentially what I'm going to do in this series is develop a simple 2D game in both at the same time. Again, I am not an expert on either product. I've used both a bit. I've used hundreds of game engines over the course of my career and dozens of different programming languages. So learning new stuff isn't really that overwhelming for me. But essentially, I am going to be learning it just before I am teaching it. So there is going to be a certain aspect of inefficiency in what I teach. So do not look at me as a subject matter expert. I am just showing you the workflow in each. I am probably not showing you the ideal workflow, but hopefully I'm showing you enough to make it interesting. And I think the most interesting thing of what I'm doing here is I'm actually going to break down what it takes to make a 2D game into composite chunks. Things like displaying a graphic on screen, handling input, your game event loop, state changes between game scenes, physics, platforming, all those things. I'm going to break down into the different chunks that actually make up a game, and then I'll look at how do I do this in Unity, and then how do I do this in Unreal, and then I'll move on to the next chunk. How do I do this in Unity? How do I do this in Unreal? And on and on and on you go until you've covered all of the things you need to know in both tools to be able to make a 2D game. Now, it's going to take a long time. I'll admit that up front. This is probably going to take me months. Hopefully it's interesting enough that you kind of keep tuned in. But when I'm done, other than having two fully complete Unity and Unreal tutorial series that should hopefully be useful to you, you will also have the most direct comparison between the two engines. And that's kind of important. That's something that's sort of lacking out there. There are a whole lot of people, and I mean a whole lot of people, searching for what's better, Unreal or Unity. And it's not a simple question, to be honest, because it really comes down to it depends. In some ways, Unity is superior to Unreal. In some ways, Unreal is superior to Unity. And the big part of it ultimately comes down to your particular preferences and needs. Now, when we look at the base stuff, we'll start with some of the comparisons between the two. Let me pause for 1 second and see this graphic up on the series, and this is actually the name I'm going to use for the series. It's going to be Unity versus Unreal, a Game-from-Scratch tutorial series, I think. It might be a little long-winded, but I'm going to use a name somewhat like that. But that is sensationalism. I am not really comparing the two. I'm just doing the same thing in both. It's pointless to compare the two because, as I said, it all comes down to personal preference. However, we can take a look at the similarities and the differences right up front because some of these things might be important to you and some of these things may not. Now, if you're in game development and have never heard of either of these, I'm kind of shocked, but I'll give you a quick overview. Basically, they are complete 3D engines. They've been around forever. Unreal was, I think, about 97 it became a product, whereas Unity was a Mac OS only product. God, probably 10 years now, maybe even longer. So these are products that have been refined and refined and refined and refined and refined to shape what we've got here. They took a bit of a different direction. Unreal Engine started, it's kind of predictable by the name, as the engine powering the game Unreal. So Epic made the game engines, and actually a company in my old hometown of London, Ontario, named Digital Illusions, made the game Unreal. And then they took the game engine and sold it, which was kind of revolutionary for the time. There weren't too many people doing this. There was a company called Renderware from Criterion that made a product called Renderware, which ultimately Electronic Arts bought and destroyed. There was Gamebryo, which is still kind of around. Used to be called Numeric Designs, I think was the company that made it. And it's pretty much gone the way of the dodo. There's Havoc with their tool suite, including the Vision engine. I've actually got some Project Anarchy tutorials on Game-from-Scratch if you want to take a look. But for the most part, there have been... Oh yeah, and there's Crytek with their Cry engine, which has always been kind of the redheaded stepchild in the industry, if we're honest. Oh, and Source. And Source releases a game once every 7 years, so they kind of get forgotten about. So that brings us back. The two big winners in this segment are Unity and Unreal. There are others at the big bundled commercial engine level, and then there's a lot of more code-oriented level, either libraries or engines, things like SFML, libgdx, XNA, monogame, phaser, etc. All these other game engines are available there that are a little bit less, a little bit more code focused, a little bit less world editing focused, and they feel kind of a different niche. So it is a little bit confusing comparing them, but as straight game engines, the tool sets for Unity and Unreal are very similar. Let me just take a quick boo here. This is Unreal. Your world editing is here. They both, again, started off as 3D, but the rise of iOS and the fact that 3D these days is actually just, 2D these days is actually just 3D faked. They've both given more and more focus on the 2D aspects. So here is the editor. Here's where your world, you place it, you put primitives in the world, shape them, set their properties, etc., etc. A whole ton more behind the scenes. There's kinematics in here, there's landscape shaping, there are this old CSG stuff from the way that Unreal used to work years ago. Then there's like blueprints and coding and such. We won't even touch on that quite yet, but we're going to be doing a whole lot of that in the future. But more or less, you kind of place your world, define its properties, add components. They're both component-based engines, which means that you build your objects in the world via composition. So if something has certain properties, you just add it as a component. Both Unreal and Unity take the exact same approach. Now we'll go over here. This is Unity if you've never seen it. Same kind of stuff, maybe a little bit less pretty, but your items in the world, their properties, components are added to it, your scene graph making up the world, your various assets available, etc. And both of them allow you to inside your world placement, you can play it directly, like so. And I'll stop that. Now I'll go back over to Unreal, and I'll hit. And now you're playing the game. I'm not actually sure what the controls are on this game, so I can't really show you much more than that. But they work very, very comparable. They're world composition tools with live code links to properties you're setting. Now the coding is generally actually done elsewhere, and that's going to actually create a bit of an issue for me on how I'm going to do this tutorial series, because both give you choices. Now, one of the catches is Unreal 3 was a different beast. Unreal 3 used to actually be heavily, the engine itself was written in C++, and you didn't generally touch that. You implemented your game, for the most part, using Unreal Script. Unreal Script was this C++-ish-esque in-house scripting language they made, and I was never really a big fan of it, in all honesty, because I would rather use an off-the-shelf scripting language if an option, especially because that allows you to transfer in your existing skill sets, makes hiring easier, it makes it so generally you advance with the language, makes the resources and materials available bigger and better, etc. But in Unreal 4, they actually moved to something called Kismet, and Kismet is a flowchart-based or graphical-based visual programming language. You draw nodes of logic together to make things work. And these go together to be called something called a blueprint. So let me just show you quickly. So hopefully this one has one. I just did the install, so you're seeing all the welcome tutorials here. Let me just... yeah. I wonder if I can just X out. There we go. So here is your Kismet editor, and no, there's nothing on the default. Crap. So basically all you do is build using nodes. Like here's the event tick node, which would be kind of like your tick in a game loop. So this will fire every single tick. It's got one parameter, which is the delta in seconds, and then you build nodes out of it. So let's say if we needed a logic branch here, let's wire this delta in on the condition. So is not compatible to bool. Okay, so I'd have to use a conversion one here. Functions. You can build graphical nodes of functions, etc. This is something I don't really want to cover in too much detail yet, but this is the programming interface behind um, behind Kismet. And as you can see, like there are so many of these. Like there's tons of them, and you just kind of string them together. Outputs from one go to inputs of the other. So in this conditional example, for example, whatever your Boolean condition comes in, so I would have to convert this delta seconds into a bool, which makes no sense. But I need to turn a yes no to come into this branch. So I need a yes no value that came in. But then I would have these two connections that come out. So on a true, do this, or on a false, do that. So here, let me just see if I can actually. So a variable. Nah, it's not easy enough. I could have like a global variable like is player alive and feed that into the branching condition and then branch out to yes or no, and they feed off to whatever else, to whatever else, to whatever else. And basically you can tie all of your code together visually using this Kismet or creating these blueprints. However, the other option is to use C++ as basically a scripting language. They've done some pretty cool job of making it alive behind the scenes connection between the two. You just kind of go open Visual Studio, it generates the code, and now you can actually use your project in the Visual Studio side of things. So you're running your code in C++, etc. So you control your various game objects. You switch over, you make a change or whatever, and they're live back to the editor. It's a very impressive feat they've done there. Now, on the other hand, so here, for example, it's some of the code they've done. So test character. Here is the test character that you're controlling. So you can see here, controlling the cameras, etc. Unfortunately, my IntelliSense isn't working yet. That requires some fixing. I don't think I've done a build yet. That would be part of it. But anyways, you can write it in your IDE of choice, be it Visual Studio or Xcode, and do your quote-unquote scripting in C++ if that's your preference. Now, it's modern-style C++, so you don't generally have the nasty memory issues. It normally follows RIAA for its initialization, which means that when an object goes out of scope, it takes care of what it owns. So a lot of the traditional hiccups of C++ aren't quite there. It's also probably a far more complicated system. So I have a choice basically between Kismet or C++ going forward. Now, I don't like working in visual editors. I don't like the idea of working this way. It's counterintuitive. Scripting in code is actually more logical to me. But it's something new. I'm willing to try it. So ultimately, I need to pick one. I can't do both because that will ultimately result in me making 3 tutorials instead of just 2. So all of my code examples are either going to be in Kismet or C++, or one of the nice things about Unreal Engine is actually a bit of both, because you can create a C++ object and, as say, a blueprint, and then inherit it or implement it in Kismet. And amazingly enough, you can actually do the opposite and inherit it in C++. So there is the option of mixing and matching. Unfortunately, that is going to require you, as the viewer, to understand either C++ and Kismet, not or. So let me know in the comments which one specifically you want me to cover, Kismet or C++. I have a strange feeling C++ is going to be the winner there, but I will follow the will of the community. Now, at the Unity side of things, coding is done a bit different. This default was actually done in C#. There are, to my knowledge, a couple of options when working in, as you can see, it's automatically hooked up to MonoDevelop on the back end. I would actually switch that out to Visual Studio. I prefer Visual Studio to MonoDevelop. Both are now free, so it's a non-issue. But you'll notice the code here is actually C# behind the scenes. It's mono, technically. So it's not quite. It's not C#5, as you would know from Visual Studio. There are some differences. It was somewhat obsoleted. I haven't actually looked at what they've implemented in Unity 5, but as of Unity 4, it was pretty much 2 or 3 versions out of date with some of the new features added. So it is a version of C Sharp, a slightly out of date version of C Sharp, but nonetheless a version of C Sharp. Full disclosure, C Sharp is probably, on a general purpose level, my go-to programming language. If I need to write something for myself and a language isn't being dictated to me, I would probably use C Sharp. So going forward, for the Unity side of things, I will definitely be using C Sharp. However, there are 2 other options. There's also Unreal Script. Sorry, I gotta stop screwing that up. Unity Script, which is basically JavaScript. They've implemented ECMA Script, which is the formal name of JavaScript these days, with some changes and extensions. But for the most part, it's just JavaScript. So you have the option of writing or scripting in JavaScript if you want, or in Boo. Boo is a Python-derived language. The reality is absolutely nobody uses Boo. I'm not really sure why they supported Boo. There's probably a reason for it, but none of the tutorials, none of the documentation, none of the anything is going to be in Boo. And I'm not the world's biggest Python syntax fan, so I'm not going to go down the Boo road either. But if you are like a diehard Pythonite, feel free. At the same time, to be honest, when you're working in Unity, the end result starts looking very similar. There are obviously differences. Your Unity script version is duck type. So it's a compiled type that things start to work, whereas Unity itself is a compiled language. So you'll see the way variables are handled. You can actually hang yourself a little bit more with Unity script as opposed to C Sharp, but the code ends up looking 90% identical, so it's not going to really make much of a difference. But on that side of things, I am going to be using C Sharp, and on Windows, I am going to be probably using Visual Studio as my IDE. Now, the nice thing is Visual Studio is now completely free for teams under 5, so just go ahead and get it. There's nothing holding you back now, other than you need about 8 gigs of space to install it, and that's it. So I'm going to use Visual Studio. In my opinion, it's the best IDE available on the market across all platforms. So you do have the option of using MonoDevelop or Xamian Studio or whatever it's called now, and it's a good tool. I like Visual Studio better again. And then on the Unreal Engine side, you've actually got the option between Xcode if you're working on Mac and Visual Studio if you're working on Windows. And I hate Xcode, to be honest, with a passion of 1,000 dying suns. So I'm obviously going to work on Windows, and I'm going to use Visual Studio. Now let's take a quick moment, and we'll talk about some of the strengths and weaknesses of Unity and Unreal. Now, the first one, and the biggest thing, and the thing that started this entire series off in the first place, is money. Money is key. And up until recently, they took a very different approach with very different drawbacks and negatives. There was kind of a free-ish version of Unity that took a royalty after the fact, and Unreal's always been the same thing. It's a flat royalty. I believe it's 5% of gross revenue, not profit, revenue. So basically 5% of what you make before you even start thinking about profits goes to them after the first $3,000. So if you make a small game that makes just a little bit of money, you pay nobody anything, which is nice. But they used to have a $20 a month subscription charge. As of GDC this year, in 2015, they got rid of that subscription. So now anyone can download and use Unreal, and you just pay 5%. That's a nice, straightforward royalty system. It makes sense. You've got to make a little bit of money before they even start coming. And then once you get to that $3,000 threshold, you start paying them some money. Now, if you think about that for a second, though, if you make the next Call of Duty and make $1 billion, they're laughing all the way to the bank. But at the same time, if you make the next Call of Duty, you don't give a damn. You just made so much money, you're laughing all the way to the bank. 5% is a very, very reasonable royalty. And just to put something into perspective, it used to be so much more. The world of game engines has opened up so much, but it used to be if you were using a product like Unreal Engine or Havoc's Vision Engine or Renderware or the Talon engine that Blood 2 and No One Lives Forever, etc. were all powered by, etc. All these commercial engines that were available 5-10 years ago, your royalty was either you paid out a flat fee of millions of dollars, or like 15, 20%. So 5% is peanuts compared to the way it used to be. Now, bigger studios obviously had more negotiating power, which is kind of ironic because they're the ones that would make the most money. But your smaller, your A studios, or what are now actually considered indie studios, were paying out a huge royalty to have access to these engines. And it kept companies like the makers of Tropico, etc., from using any of these tools because it was actually still economically viable to roll your own. Now it's not. It's really hard to justify making your own game engine. It's probably, in all honesty, a stupid thing to do because you're not going to do it for less than 5% of your revenue. It just can't be done. So that's the way that Unreal is priced at. So 5% over a certain amount of income threshold is going to them, period. But the nice thing is you're only paying them if you're bringing in revenue. Not necessarily making money, but bringing in revenue. So that's fair, and it's a straightforward thing. And the nice thing is without that subscription fee, you no longer have any upfront costs. Before, let's say you had a team of 10 people, all working with it, all needing their own license, all at $20 a month. $20 a month doesn't sound like much, but all of a sudden that's $200 for your team to work together per month before you've even got anything to work with. Well, that's gone now, and that's awesome. Now let's flip over to Unity for a second. Unity's pricing structure used to be confusing as hell. Basically, they had the basic version and the pro version. The basic version was free up to $100,000, at which point it was a percentage of profit paid out. And then they had the pro version, which you bought outright, either for $75 a month or $1,500 per platform. That one's a key. Per platform, not as in Windows or Mac, but as in iOS, Android, Windows would have been $4,500 to make that happen. And the two versions actually had different functionality. So you had better lighting, you had native plugin support, you had profiling, etc. You had all these things that were built into the premium version that weren't in the basic version. And yeah, that kind of sucked. But on the other hand, you could buy Unity Pro outright. And if your game made $100 million, you made $100 million minus the revenue cost. So if you thought you had a surefire hit on your hands, and everybody seems to, but if you thought that was the case, you never had that profit share that the Unity took, which was pretty awesome. However, things have been streamlined now. I think pretty much better in all regards, but there's some catches here. But basically now when you license Unity, there's a free version and a pro version. The pro version has no splash screen, analytics tools, access to the beta, and that's about it. And it's $1,500 per seat. So you have 10 developers. It's going to, or $75. Sorry, I know it's $75 a month. The per seat price might have changed, or it might be subscription only now. So anyways, it's $75 per developer per month per seat. So if you have a team of 100, you're looking at $750 a month to use Unity. However, that basic version, the one with the splash screen, is completely free. It's the same thing with the same functionality minus the analytics and access to the beta, and I said the splash screen. But as long as you made less than $100,000 last year, you're golden. So that's the key. You pay with Unity a set monthly fee per developer, or you go with Unreal and you pay 5% of the end result. Now, which one works out best for you? Who knows? They both have their strengths and weaknesses. Like, again, a runaway hit, Unity's the best call. Small development team, Unity's probably the best call on a moderate hit. Most other cases, from a financial point, Unreal's probably the best hit. So, at the same time, the difference between $75 a month for people that are making over $100,000 or nothing, and then a 5% royalty, those are both almost pittances today. So the price distinguishing factor isn't the big deal it used to be. And you can get started with both of them absolutely free and have everything going out of the gate. So be aware that there is still a difference, but it's not the difference it used to be, and it costs you nothing up front, which is what enables me to make this series and for you to all follow around without spending a single cent, which is awesome. There's a couple other areas that are kind of important, minorly important. Unity has slightly, minusculely better platform support. They're on a couple environments that you're not available on Unreal, like BlackBerry, Tizen. I'm not sure about HTML5 right now, and a few others. PlayStation Mobile, which was just discontinued, but it's on a few more platforms. So if you're trying to target those specific platforms, obviously you're going to lean in favor of the Unreal. Of the God, this is going to be confusing. Why they both have to start with UN? The Unity engine has a small edge there. Now a big edge though comes to Unreal. You get the source code. It's on GitHub. You've got the source code to the engine. This makes debugging as easy as it gets. To be honest, the majority of you, the vast majority of you, aren't going to use the source code. You're not going to extend the engine, but you will benefit from the community doing that work. And if some horrible tragedy should happen to Epic, you have all the source code. Life goes on. Whereas a source code license for Unity is a negotiated, purchased, separate thing. You don't have it. So if that's a distinguishing factor, be aware of that. And when it comes down to functionality, you kind of look at how they both kind of grew. Unity started life as sort of a small Mac hobbyist thing, and then the world of iOS happened and it blew up, and games got more and more advanced, and Unity got more and more graphic functionality. Unity's results have always been a little uglier than Unreal. On the other hand, Unreal's always been a little bit harder to use than Unity. And they're both moving towards the center. Every release, Unity gets better looking. And Unity's at the point now where me as a small team, without lots of graphic artists, technical directors, script writers, etc., working on it, I'm not going to tax out the graphic effect. Most people aren't. So we're kind of at the point where there's almost graphical parity between them, and we're kind of at the point where there's almost an ease of use parity between them. Now, one area where Unity absolutely smacks the crap out of Unreal is learning materials. There are books galore on Unity. There are literally hundreds of them out there. Now, the catch is Unity 5 is not Unity 4, is not Unity 3, and so as time goes on, a lot of those books are starting to get outdated. However, Unity's evolution has been very gradual. So most of what you see from these old books is still applicable. And the newest books, since it's such a mass market product, there are already a ton of them, and there are more coming. So in terms of learning materials, etc., there is a ton available for Unity. Whereas Unreal, there was a handful of books made, but unfortunately a lot of them were from the era of Unreal Script. And when they dropped Unreal Script, they made all of those books completely useless. So now there's not much. In fact, I believe there's one book. As one of my posts, it's going to be a post, not a video, but I will round up the learning materials available for both products. So I will give you a list of all the current books available for the newest version, the best tutorials that I can find, and then we're going to get to this nice part. Both Unreal and Unity have done an amazing job of providing tutorials and documentation for you. So that's an area where they're almost a wash. They both have very, very good documentation, which is nice. So realistically, picking between the two is like picking between a brown shoe and a black shoe. Do you want a brown shoe? Do you want a black shoe? There's some merit to wearing either, but the decision ultimately comes down to you. So again, this series though, I'm going to take and implement a game. I didn't mention that. I'm going to be using these game assets from... Let me just come up, search for programmer art. Ooh, look, hey, I'm the first link. That's cool. This fellow right here, Chris Hillenbrand, is doing a complete 2D game art assets project. You can see it right here. One of the posts on it. And he's making these characters, animated characters, backgrounds, and graphics available to do a complete platforming style game. I'm going to use these resources as they become available. That way I don't need to focus on art. It's not not an area I like to focus on too much. But if you're sitting there going, well, how the hell do I create this stuff? Well, the nice thing is there is this tutorial series going on that will actually show you how to use Inkscape, which is a vector-based graphics program to draw all these things. So if you've got Inkscape, or you can use Illustrator or iDraw or whatever to make these graphics for your game, or you can just download and use the stuff that he's providing. But that's what I'm going to be using in the background to create this simple 2D platforming game. Oops. 2D platforming game in both engines. So that's an overview of what I'm going to do, and a little bit of a quick look at Unreal and Unity and the differences there. The key thing, and I probably shouldn't have waited a half an hour in to describe this, is there isn't that much of a difference anymore. The way they work is completely different. And you'll see that from the workflow when I'm done here. You can look at both and go, oh, this is so much better. Or if you've already decided you want to use Unity, you'll have a complete Unity tutorial series to follow along with. Whereas if you want to use Unreal, you can have this complete series when we're done as well. So hopefully it'll be useful to you, even if you've already made up your mind. But if you haven't made up your mind, seeing side-by-side workflow, I hope, should be invaluable. Now, once again, this series is just starting, and it's going to take me forever, because literally I will have to learn one, implement the other one, implement next step, implement next step, implement next step, implement on, for about probably at least a dozen steps on each side, and then actually roll the entire game out from it. So probably 18-ish videos per platform, so we're looking at 36 videos at probably at least an hour a piece. Yeah, there's a lot of work ahead. So the key thing is, any feedback, any direction, any ideas, any suggestions you have for this series, get them in now. Because the earlier you get them in, the earlier feedback I've got, the more I can respond to it. So if there's something you want to see covered, if there's something you think is a stupid idea, if you want me to work in Kismet instead of C++, or C++ instead of Kismet, or for some strange reason you really want to see Boo, let me know, and I will try my best to incorporate it in. Also, if there's certain things you want to see in the game, you want to see parallax background, you want to see streaming levels over the network, you want to see custom shader implementations, or something along those lines, let me know, and I will try to incorporate them as early as possible into this. So again, I'm going to be creating a Game from Scratch tutorial series for creating a simple 2D game in both Unreal and Unity at the same time, so you can see how both work, and hopefully you will learn something. Thanks for your time. I think that's it for now. Cheerio. Bye.